Hi, welcome back. It's going to take me a little bit to figure out what the right introduction is for this kind of thing. I'm not really that used to talking to a camera. I usually talk to an audience of students. But anyway, in this video, we're going to be going through some truth table problems again. Specifically, we're testing for validity. And these are going to be of the intermediate level of difficulty. And before we get started, I wanted to say a quick note on what that means, because truth tables are honestly not that difficult, regardless of whether you're doing easy ones or hard ones. The thing that goes up in difficulty is actually just how hard it is to keep track of which column you're on, which truth value you're looking at, right? Truth tables really lend themselves to really small mistakes that can then, of course, just kind of ruin the entire thing. So one of the things that you should practice and that I'll be doing in this video is just pacing yourself, making sure that you're looking at the right truth value, looking at the right statement, so on and so forth. Other than that, we just consider more statement letters, and of course that results in more rows on the truth table, right? That's not exactly a difficulty thing, but it does make the truth table a little more tedious. In a future video, we'll cover abbreviated truth tables, which saves you a whole lot of time and effort and messiness at the price of them being just a little more involved. Also, just a word of advice, I recommend pausing the video whenever I show one of the truth tables and just filling it out yourself and then seeing if there are any mistakes that you made or anything like that, right? So basically doing it twice. The biggest thing in logic, whether you're doing truth tables, truth trees, proofs, Venn diagrams, what have you, it's just practice, right? Doing the same thing over and over and over and over again. That's how you master this. Okay, so enough intro. Let's turn around and get started on some truth tables. So see you in a minute. All right, so let's go ahead and get started with our truth table. Now, for this truth table, I'm going to go ahead and I'm going to start with the conclusion, just because the conclusion is going to be nice and easy. It's just a negation, right? So not C. So all we need to do is just look at the column of truth values, right, underneath C. We just have to invert those. So C is true, 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 false, 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 which means that not C is going to be false, 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 true, 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 true. And we're just going to do the exact same thing here for not D, right? So D is true, true, false, false, true, true, false, false. So we're going to do the same thing here. We're just going to invert it, right? So false, false, true, true, false, false, true, true. Now it's okay to work through those pretty quickly because it's just a negation. It's pretty straightforward. My advice when you're working on the more complicated statements like the one that we're going to move on to now, take things slowly. Seriously, it's very easy to make mistakes. I've made mistakes doing these, and I've been doing this for far longer than I want to admit. So just one step at a time. All right. So first, we identify the main connective. In this case, the main connective is this biconditional. And we can't evaluate this main connective because we first need to know what the value is of this disjunction, right? So you always start inside and work outside. So, okay, let's go ahead and evaluate the disjunction. A disjunction is false if and only if both of the disjuncts are false. Otherwise, it's true. So we're going to keep that in mind. I'm going to go ahead and I'm going to mark off, here's C, here's E, and we're going to evaluate these, right? So we're going to evaluate this disjunction. So, okay, starting off with the very first row, E and C are both true, so that's going to be true. And remember, it's going to be true if even just one of them is true. It's false only when both are false, right? So second row, C is true, so that would make this true. Third row, they're both true, so that'll make this true. Fourth row, C is true, E is false. Having just one of them be true means this is true. Fifth row, we have E as true. Sixth row, they're both false, so that makes this false. Seventh row, E is true, so that makes this true. And eighth row, they're both false, so that makes this false. Now, I went very, very carefully, but you should double check anyway. It's always possible that I'll make a mistake while I'm recording, make a mistake that I somehow makes it past editing and somehow ends up on your screen, right? I'm not perfect. Make sure that you're checking along, right? And if I do make a mistake, let me know in the comments, just because it's valuable information for me to have. Okay, So now that we have that, let's get rid of these arrows. We now have all of the information that we need to evaluate the main connective, right? So we can evaluate this biconditional. So the biconditional, just to remember, remember your logical connectives. Biconditionals are true when both of the components of the biconditional are of the same truth value, and they're false when the components have different truth values, okay? So let's go ahead and do this one step at a time. For the very first row, D, right, so here's what we're looking at. D is true and the disjunction is true, so this is going to be true. The second row, D is true and the disjunction is true, so this will be true. Third row, D is false and the disjunction is true, so they have different truth values. That means that, that it's going to be false. For the fourth row, they have different truth values, so that'll be false. For the fifth row, they have the same truth values, so they'll be true. For the sixth row, they have different truth values, so that'll be false. For the seventh row, they have different truth values, so that'll be false. And for the eighth row, they have the same truth values, so that will be true. All right, I am going to go ahead now and highlight the main connective for each one of these premises and the conclusion, right? And this just makes it easier to cut through the stuff that we don't need to consider when we're evaluating the argument for validity, right? So what we're looking for is any row that has all true premises and a false conclusion. If we find a row with all true premises and false conclusion, then the argument is invalid, and that's because valid arguments can't have that. They can't have all true premises and a false conclusion. And if we don't find any row with all true premises and a false conclusion, then we know that the argument that we're dealing with is valid. All right, so let's start at the top. Very first row, we see that we have a true, first premise is true, second premise is false, and the conclusion is false. So this doesn't tell us anything, right? We haven't found a row that has all true premises and a false conclusion. Let's look at the second, right? The second premise is false. In the third, the first premise is false. And in the fourth, the first premise is false. And the remaining four rows all have a true conclusion. So what this tells us is that the argument is valid since there is no row with all true premises and a false conclusion. And of course, the only rows you really need to look at are the ones where the conclusion is false. Okay, so we're finished here. Let's go ahead and move on to the next one. All right, I know, lots and lots of fun, but we can make it. Okay, so starting again with the conclusion for the same reason as before, Q here is true, 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 false, 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 false. So I'll just go ahead and invert that. So that's the first four are false and the last four are true. And then for Z, we have alternating truth values, right? So true, false, blah, 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 right? All right, so let's just invert that. So that's going to be false, true, all the way down. And again, now we're moving to a more complex statement. So let's just take things slowly. We can't evaluate the conditional, which is the main connective. So we'll start off by evaluating the conjunction. Conjunctions are true if and only if both conjuncts are true. Otherwise, they're false. So they're false under all other conditions. And we're looking at Q and at U. So in the first row, both are true. So that's true. And in the second row, both are true. So that's true. In every other row, so rows 3 through 8, you've got at least one of them being false, which means that the conjunction is going to be false for the remaining rows. Okay, now that's not our main connective, of course, but that's going to give us the information that we need to evaluate the main connective. So let's go ahead and do that. So now we're going to shift our attention and we're going to be looking at the conjunction and at Z. Okay. Now, a conditional is false when the antecedent, right, the first statement, the statement before the arrow, is true, and the consequent, the statement after the arrow, is false. So whenever you have a true antecedent and a false consequent, then you know that you're dealing with a false conditional. Under all other sets of circumstances, the conditional is true. So here we have a true antecedent, right, this conjunction, and we have a true consequent. That's Z, right? So this will be true. Here we have a true antecedent and a false consequent. So this will be false. For the remaining 6, the antecedent is false, so we know that the conditional will be true. So let's just write that out. And this is why it's useful to know your truth functional connectives just right off the top of your head, right? To know the conditions under which they're true and they're false. It can make your life so much easier. It just makes things faster, right? So notice if the antecedent is false, then it doesn't really matter what the consequent is, right? Because if the consequent is true, well, false antecedent, true consequent gives you true conditional. If the antecedent is false, well, if the consequent is false, false antecedent, false consequent gives you a true conditional. So you get a true conditional either way when the antecedent is false. So it doesn't matter what the consequent is. Okay, so now we have all of our truth values laid out. Let's grab our highlighter and highlight the columns that matter to us, right? And that's, of course, the set of truth values underneath the main connective. So for this premise, the main connective is the conditional. And then for these, the main connective is the only connective. So we'll just go ahead and highlight those. Okay, and now we can go ahead and evaluate this thing. So again, the only rows that matter are the ones that have a false conclusion. So that's just the first four. And now we're just looking for any row that has all true premises and a false conclusion. And looking at this, I can see it right here, right? And there may be more than one, that'd be fine, but all you need is just one. So the fourth row has two true premises, and there are only two premises, and the false conclusion. So all of the premises are true and the conclusion is false on that row. That wouldn't happen if the argument were valid, so we know that the argument is invalid. All right, let's just move over to the last one. So this one's just a little more complicated. It's got two premises that are a little more complex than just a typical negation, right? As before, we'll start with the conclusion because that's easiest, right? So here the conclusion is not Q. So we look at Q. Notice its truth values. It's true, true, false, false, true, true, false, false. So this will just be false, false, true, true, false, false, true, true. Okay, now we can move on. Let's just work backwards, in increasing difficulty. So we'll pay attention now to the second premise, right? So P and not R. Before we can evaluate the conjunction, we have to evaluate the negation. So we'll look at R, right? And R is true, false, true, false, true, false, true, false. So not R must be false, true, false, true, false, true, false, true. Easy enough. And now we're going to go ahead and evaluate the conjunction. So we'll look at P and we'll look at this negation, right? And again, if both are true, then you know that the conjunction is true. And if either one of them is false or both of them is false, or both of them are false, then you know that the conjunction is false. Again, methodically, right? Let's move through this slowly. So for the very first row, P is true, but our negation is false, which means that this conjunction is false. For the next row, both of these are true. P is true and the negation is true, so that makes this true. Third row, the P is true, but the negation is false, right? So not R is false, which means that this is false. Fourth row, they are both true, so we will mark this as true. And then for the last four, notice P is false for all of them. So you don't have to worry about what not R is, right? You just know that they're all false. Nice, simple, straightforward. Okay, now let's move on to the really complex statement, right? Which is our very first premise. So we can't evaluate this conditional until we've evaluated this disjunction, and we can't evaluate this disjunction until we've evaluated this negation. So we'll start there. Let's turn our attention to Q. And Q is true, true, false, false, true, true, false, false. So the negation is going to be false, false, true, true, false, false, true, true. And now we can evaluate our disjunction. So let's turn our attention to R and the negation, right? And again, the disjunction is going to be false if and only if both of the disjuncts are false. Otherwise, it'll be true. So here, R is true. So that tells us the disjunction is true. And the second one, both are false. So we know that this is going to be false. Here, the next two rows, right, this negation is true. So we know that this disjunction will be true. For the next two rows, on this one, we have R is true and the negation is false. So this will be true. And for the sixth row, both are false, so this is going to be false. And then for rows 7 and 8, so in 7, both are true, so this will be true. And in 8, we have this being true, so this will be true. And now we can finally go ahead and evaluate our main connective. So I'm going to focus on P and the value of the disjunction. Okay, remember, conditional, false when the antecedent is true and the consequent is false, otherwise true. So P is true and the disjunction is true, so this will be true. P is true and the disjunction is false, so this will be false. P is true and the disjunction is true, so this will be true. P is true and the disjunction is true, so this will be true. And for the last 4, P is false, so we know that every one of these is true. Turns out there's only one row where the conditional is false. Now, again, let's go ahead and highlight our main connective so we don't make any mistakes down the line, right? So we could focus our attention on the truth values of these premises, right? And not on any of their components. And now all we need to do is see if we can find a row that has all true premises and a false conclusion. So starting with the first, we can see that the second premise is false. Moving on to the second, the first premise is false. The third and fourth row, the conclusion is true, so we can ignore those. Here for the fifth row, we have the first premise is true, but the second is false. And for the sixth row, the first premise is true and the second is false. And then there are no other rows that have a false conclusion. So there are no rows in this truth table with all true premises and a false conclusion. So we know that the argument is valid. And that's all there is to it. All right, so again, there's really not much to a truth table. It's pretty straightforward to evaluate it. You just want to make sure that you are cautious, right? You want to make sure that you check every step, because the easiest way to mess up a truth table is to look at the wrong column or look at the wrong truth value or what have you. I'm going to have one more video. I shouldn't say that. I'm going to have one more level of difficulty of video, right? Which is I'm going to upload a video on some hard truth tables. It's kind of just going to be more of the same. I will cover a couple of truth tables, or maybe one at most, that requires 16 rows. And again, the thing that makes that hard is just a lot of truth values to look at. So you got to make sure that you're being really cautious, right? So stay tuned if you want to see more logic videos, and I will see you in the next one.